Hello everyone, welcome back to my YouTube channel. I'm Ananya, currently pursuing my bachelor's degree in Sri Venkateshwara College of Engineering in the Department of Computer Science and Cyber Security. Today I'm here with the topic from mathematics, that is modified Euler's method. Introduction to modified Euler's method. Modified Euler's method is a numerical method used to approximate solutions to ordinary differential equations. It is an extension of original Euler's method which improves accuracy at the midpoint of each interval. This method is particularly useful when the step size is relatively large or when there is a need for higher accuracy. Steps of modified Euler's method. This method involves breaking down the problem into smaller steps and approximating the solution at each step. Step 1 is initial conditions and step size. Begin by determining the initial conditions of the differential equation, including the initial value of the dependent variable and the initial value of the independent variable. Choose a step size h, which represents the increment at which the independent variable will be increased. The step size determines the number of steps needed to be reached in desired range of independent variable. Step 2 is approximating the next value of the dependent variable. Use the initial conditions to calculate the slope of the differential equation at the starting point. Multiply the slope by the step size h to obtain the approximate change in dependent variable over one step. Add this change to the initial value of the dependent variable to get approximate value of the dependent variable at the next step. Step 3 is approximating the next value of the independent variable. Increase the value of the independent variable by chosen step size h. This will determine the new value of the independent variable at the next step. The new value will be used as the starting point for the next iteration of the method. Step 4 will be the calculating the slope at the new point. Use the new value of the independent variable to calculate the slope of the differential equation at a new point. This slope will be used to approximate the change in the dependent variable over the next step. Repeat steps 3 and 4 until the desired range of independent variable is reached. Application in population growth models. This method improves upon the original Euler's method by using a midpoint approximation for the derivative. In population growth models, the rate of change is often described by differential equation dp by dt is equal to f of t comma p, where p represents the population size and f of t comma p is the growth function. The modified Euler's method involves calculating the slope at 2 points, the initial point and the midpoint between the initial and final points. The population size at the final point is then estimated by using the slope at the midpoint to update the initial population size. Application in physics projectile motion. Here, the trajectory of an object is determined by its initial velocity and launch angle. By applying modified Euler's method, we can accurately predict the motion of projectiles in real-world scenarios. Modified Euler's method allows us to solve complex projectile motion problems that cannot be easily solved by analytically. It provides a step-by-step approach to approximating the trajectory, taking into account factors such as air resistance and varying gravitational fields. With the help of modified Euler's method, we can obtain precise numerical solutions for projectile motion, enabling us to analyze and optimize the various aspects of the motion. Application in finance option pricing models. Here it is applied to pricing options, which are financial derivatives that give the holder the right but not the obligation to buy or sell an underlying asset at a predetermined price. By using modified Euler's method, we can calculate the value of these options more efficiently and accurately. Improved accuracy. Modified Euler's method provides a more accurate approximation of the solution compared to the basic Euler's method. Flexibility. This method allows for adjusting step sizes, enabling researchers to strike a balance between accuracy and computational efficiency. Modified Euler's method is relatively straightforward to implement in option pricing models, making it accessible to a wider range of practitioners. European option pricing is also available here. Modified Euler's method can be utilized to calculate the fair value of European options where the underlying asset can only be exercised at expiration. Application in engineering circuit analysis. In engineering circuit analysis, it can be applied to analyze and solve complex circuits with time-varying inputs. This method is useful for systems with nonlinear circuit elements or when analytical methods are not feasible. It allows for the analysis of time-varying circuits without the need for complex mathematical calculations. It provides a practical and efficient way to simulate circuit behavior, especially with nonlinear elements. It can handle circuits with discontinuous inputs or sudden changes in circuit parameters. Application in fluid dynamics, Navier-Stokes equation. This method is useful when dealing with complex fluid flow problems that cannot be solved analytically. By discretizing the domain and using a finite difference scheme, modified Euler's method allows for efficient and accurate calculations of fluid flow behavior. Modified Euler's method offers a balance between accuracy and computational efficiency in solving Navier-Stokes equation. It is particularly well suited for time-dependent flows where the fluid behavior changes over time. This method also allows for incorporation of boundary conditions, which is crucial in accurately modeling real-world fluid flow scenarios. Application in computer graphics animation. It allows for the calculation of object movement and transformations over time. This method is particularly useful for real-time animation where efficiency is very crucial. Physics-based animation. Modified Euler's method can simulate physical phenomena like gravity, collisions, and fluid dynamics. Character animation. It enables the realistic movement of characters by animating their skeletal structures and joint rotation. Particle systems. This method can be used to create dynamic particle systems such as fire, smoke, or water by simulating the motion of individual particles. Advantages of modified Euler's method. Modified Euler's method is relatively simple to implement and computationally efficient. It provides a reasonable approximation for many practical applications. This method allows for flexibility in adjusting the step size to balance accuracy and computational cost. Conclusion. Modified Euler's method is a versatile numerical method with application in various fields. It allows for the approximation of solutions to differential equations, providing insights and predictions. This method enables researchers and practitioners to tackle complex problems and make informed decisions. Thank you.